We're going to take a look at the night sky and how you depict it in a drawing. Hard for some people to do, hard for me to do. So let's start by showing an astronomer standing on, maybe standing in the middle of a planetarium, looking at the dome that's overhead. Maybe the astronomer standing outside looking at the night sky. That would be either the celestial sphere overhead or possibly the dome of the planetarium. And if we begin with this, I'm going to just do it the way we often do, and that is to show north over here to the right. Okay, and that means that on this end is going to be south. That means coming out of the sheet of paper is going to be east. All right, and it means inside in here somewhere is going to be west. Okay, so if we've got that, and we know that north from our vantage point, 36 degrees above the northern horizon. If this is the horizon reading up to about 36 degrees, somewhere in here would be the star, the North Star Polaris. So we'll label that the North Celestial Pole. And likewise, if we went for this observer directly overhead, right up here, that would be the zenith. Okay, so the zenith is high up overhead. Okay, that's going to be right there. And if we're depicting what the sky looks like, the first thing you want to be able to draw is where the celestial equator is, because everything turns parallel to the celestial equator, at least in diurnal motion. So we want to start with the North Celestial Pole, start up here, and we want to measure down 90 degrees in all directions. And that'll generate an arc that starts somewhere around in here, arcs through the sky, and ends in the western horizon. So that defines the celestial equator, the Earth's equator projected out onto the sky, doesn't go through the zenith, a little bit below it. And of course that's going to show us where diurnal motion is. If we follow the sun, let's just say it's December or January, the sun will rise a little bit south of east over in here, and it'll cut through the sky. Its diurnal path will look something like this, and it'll set over here in the west a line that's parallel to the celestial equator. So that would be the sun. Let's just say it's January 15th or January 20th, maybe even the first day of winter. So that's the sun. That's a diurnal path of the sun rising in the east, moving across here, setting in the west. If we look on the first day of summer, on the summer solstice, and we look at what the sun's diurnal path is, it's going to start way over here north of east, somewhere over in here, going to cut through the sky like this, won't reach the zenith, but it'll be close, and then it's going to set somewhere in the west. So that's going to be 3 diurnal paths. And of course we can use this kind of a drawing to show what the seasons are. This would be the winter diurnal path of the sun, a short path, maybe takes 9 hours to do. This would be the path on the equinox, either the autumnal equinox or the vernal equinox in the spring, when the sun is right smack on the equator and cuts through the sky like that. Now the other thing that we might want to show on this kind of a drawing is we might want to depict the way the ecliptic is. And now the drawing begins to get a little junky. An ecliptic is not in the same plane. It's not the same line as the celestial equator. And one way to draw it is to join it as though the joining point is over here at the eastern horizon, but it's a different plane. And that's a little hard to do, but you get the idea. It's at an angle of 23.5 degrees. That's the angle from here to here. That's 23.5 degrees, showing how much the orbit of the Earth is tipped with respect to the Earth's equator.